Hi, this is the start of a series of recordings I'm going to do going through exam questions. Now this is a shadow paper which I've created based upon a real AQA Physics Higher Paper. It's paper 1. So this question is just question 1 we're going to go through now, and the reason I've created a sort of dummy question is because if you're getting towards the end of your revision, then these are essentially extra questions. You won't have seen these anywhere else, um, so they should be particularly useful because of that. Okay, now the shadow paper is essentially the same style. The question kind of matches the question from the exam, but the situation's ever so slightly different. So it just gives you that bit of extra practice. Right, so question 1, part 1, a student uses a slide in a park. The student becomes positively charged because of the friction between their clothes and the slide. Explain why the friction causes the student to become charged. Okay, so first point here is about the transfer of electrons. Okay, that's what essentially things become charged because of that transfer. So there is a transfer of electrons. Okay, that's our first mark. Now we just need to say the direction. So the student, it says here, becomes positively charged. So that means the student must have lost electrons. Electrons are negatively charged. So if you lose electrons, you become more positively charged. Okay, so the transfer is from the student to the slide. So 1 mark for the transfer, 1 mark for the direction as such. 2 marks. Moving on. Okay, so the next question. Student can be modelled as a sphere, as shown in figure 1. That's down here. The arrow shows part of the electric field around the student. The student is positively charged. Okay, so that's a reminder, we already know that. Complete the diagram by adding 3 more arrows. Okay, so the arrows are essentially showing the electric field. So the direction is important, hence the arrowhead. Now, the electric field will be pointing away from positive, okay, towards negative or away from positive, which is nice and clear. They've already given us one here, so we just need to follow that. I'm evenly spacing them around the positive charge, okay, to give a nice balanced diagram. And there we go. There's our 1 mark. Should be straightforward, that. One bit too far. Question 1 still, part 3 this time. So the student touches metal fencing, so ignore the odd typo, I'll make those. That is around the park and receives an electric shock. Explain the reason for this. Okay, so we've got 3 marks this time. That's slightly higher than the first part of the question. So we've got to make sure we include sort of 3 parts to this. The first mark is a really important one. Okay, so essentially the reason that this electric shock happens is because there is a potential difference between the student and the fence. Okay, so that's our first mark. Now remember, potential difference, that's measured in volts, often called voltage. And really what that's talking about is there's a difference in charge between the 2 things. Okay, so we know the student is positively charged, so the assumption would be the fence is either less positive, neutral, negative. It's a different charge. It could be even more positive. Likelihood is though, and we're going to come to that, it's around neutral. So the next part is this causes electrons to transfer from the fence. Okay, so that's important. Direction is important. That's our next mark there. It's the electron transfer from the fence, which earths the charge. Okay, so 1 mark, 2 marks, 3 marks, and we're done. It's important to point out that last bit, you could have had a bit of variety in there. You could have said the fence is earthed. They allow that for that final mark. You could also say charge is transferred rather than electrons. I've carried on with electrons as that's how we've done the other one. Okay, final part. The slide was made of type plastic. Some slides are made from steel. The student is much less likely to receive an electric shock after using this type of slide. Explain why. Okay, so this one's just 2 marks. Okay, and the first mark should be fairly common. So steel is a better conductor than plastic. Okay, you could say polythene. We're told that it's polythene, but plastic is fine. So that's important. It's a better conductor. That's the main reason. Steel isn't the best conductor. You know, copper is better, but steel is still pretty good. Certainly a lot better than plastic. And then there is a lower build-up of charge. You could say there's no build-up of charge as well. They allow that for the mark. You could also describe it as a smaller potential difference rather than build-up of charge. Either way, you're getting that second mark. So first mark, second mark, and we're done on that question. Okay, thanks for watching.